All right, so a quick one here. This is suitable for anybody looking to practice reducing their fractions, whether you're in grade 9, grade 10, grade 11, or whether you are practicing working with fractions with factors. So, number one, we're going to use the property here that if we have one numerator, basically one factor that's showing up in the numerator and denominator, they are able to cancel out. That's really a fancy version of 1. They're able to cancel out and we can multiply by 1. If we're multiplying several fractions together, we just multiply those by multiplying their numerators and then multiplying their denominators separately. So if that's the case, if I'm handling a multiplication of several fractions like this, then what I'm really looking for are some factors that are common to the numerator and denominator and canceling those before it gets overly complicated. So right away I recognize, hey, there's a 4 in my numerator and my denominator. 4 over 4, that just equals 1. There's a 9 in my denominator and in my numerator. 9 over 9, that just equals 1. 5 over 5 just equals 1. 7 over 7 just equals 1. So really I'm working with 1 times, let's see here, 1 times 3 times 1 times 1 times 1 over 1 times 1 times 1 times 1 times 2. Nice and easy. So that is just 3 over 2. Fantastic. I cannot break this apart. I cannot reduce this anymore because both of these are prime numbers. Now, if that's the case, great. Let's use that property even a little bit further to handle fractions that have greater numerators and greater denominators. We'll use the same concept, looking for pieces that show up in the numerator and denominator. I see my 9s, I see my 5s, and then that's where it gets tricky. So here we can simplify it a little bit further because I can see right here I have a 12 and I have a 4 and a 3 in the numerator. Now those are not the same numbers, but I know that I will be multiplying my numerators together or multiplying my denominators together. So really I can see this 12 as a 4 times 3. And if I view this 12 as a 4 times 3, then I can cancel out the 4, the 3, and the 12, which is my 4 times 3. So now I'm just remaining with a 50, a 10, and a 24. Again, I can break these down into their factors. 50, well, that's just 5 times 10, right? And now I have a 10 in my denominator, a 10 in my numerator. I'm left with 5. Remember, my 50 got turned into a 5 times 10 here. I'm left with 5 over 24. I cannot reduce these any further because 5 itself is not a factor of 24, and 5 is a prime number. So I'm working with 5 over 24. You'll notice here what I'm not doing, what I'm not wasting my time doing, is multiplying my entire numerator, my entire denominator, until I have reduced as far as I can. Now sometimes our expression has more than just multiplication, it has division as well. Well, I know if I'm dividing fractions, you might view that as, you might view this with a crisscross method, something like this, or you might view it as flipping your numerators and denominators of what's being divided. So that's how we're going to handle it right here. This is like 4 over 9 times 3 over 5 times 12 over 9, where we flip this fraction, times 36 over 15, where we flip that fraction, times 50 over 24. We only flip the fractions that are immediately following a division sign. Now that I have myself a multiplication of fractions, I can go about this in the same way. I can cancel out different factors that I see, but right now I don't see any factors that are showing up in the numerator and the denominator together. So we're going to need to get a little bit creative again. I see a 5 here, and I know my 50 can be broken up with 5 as a factor. So 50 will become 5 times 10. My 5's cancel out. Nice work. My 36 can be turned into 4 times 9. I cancel out that 36. I cancel out a 9 and a 9. And am I looking for anything else? Looks like I see a 3, and my 15 can be broken up into 5 times 3. So my 3's will cancel out. Again, I can break down this 12, can be seen as a 4 times 3. My 9 can be seen as a 3 times 3. So one of these 3's cancels with this 3 right here. And now this is getting really messy, right? So let's try rewriting it before we look for any more factors that we can cancel. So we're working with 4 times, and really here we're working with 4 times this 4 times this 4 times this 10. all divided by this 3 times this 5 times this 24. 4 times 4 times 4 times 10 divided by 3 times 5 times 24. Now I'm hoping if you're watching this video, you're comfortable using a dot for multiplication right here. Excuse me. Now, a quick note is that if ever I see even numbers in my denominator and in my numerator, I know I will be able to divide both of them by 2. But right here, I see my 24. I can break that up into a 6 times 4. And that allows me to cancel out one of my 4's. And then even further than that, what I'm working with, this 6 is really 3 times 2, right? And this 4 is like 2 times 2. So I can cancel out one of these 2's with one of these 2's. And again, now it looks like it's getting a little bit heavy to follow, so I'll start copying it out again. I'm left with a 4, a 2, and a 10, a 3, a 5, and a 3. That is 4 times 2 times 10 divided by 3 times 5 times 3. Now the key here is we can really break these all the way down into their prime factors. So right here I have this 4 is not a prime number, this 10 is not a prime number. I could break those down even further just to double check that I don't have any common factors in my numerator and denominator. That is 2 times 2 is my 4, times 2 times 2 times 5 is my 10, divided by 3 times 5 times 3. What do I see right here? I see my 5's together in my numerator and denominator. I can cancel those out, and I'm left with 2 times 2 times 2 divided by 3 times 3. Because I cannot break those down any further, because those are all prime numbers, now I can perform my multiplication to end up with 2 times 2 is 4, times 2 is 8, times 2 is 16, over 3 times 3, 16 over 9. So we're working down right here as we work our way through this problem, and you can see some of these steps get quite complicated, but you can always break it down into more steps if your math mind prefers. Now we can use these same concepts to break down a fraction with two big numbers in itself. Right away, if I take a look at this, I recognize, hey, this number's even and this number's even. Because of that, I can divide both by 2 right away. I can get my calculator out. 324 divided by 2, I'm working with 162. And 1,296 divided by 2, I'm working with 648. Well, I notice again these are both divisible by 2, so let's do that. I'll divide by 2, divide by 2, and I'll work with 162 divided by 2, that is 81. 648 divided by 2, that's 324. Now at this point, okay, I no longer have an even number in my numerator. That means I will not have any more even factors that are shared between my numerator and denominator. So then it's time to look for some odd factors. Well, the easiest odd factor to look for is 3. Let's check. Is 81 divisible by 3? Yes, it is. I get 27. Is 324 divided by 3? Easily? Yes, it is. I get 108. So I'm working with 27 over 108, where I've divided my numerator and my denominator by 3. And the key there, what I'm looking for is, are these divisible without using any decimals, right? So now I'm working with 27 divided by 108. Again, I will try 3. Can I divide 27 by 3? Can I divide 108 by 3? 27 over 3 is 9. 108 divided by 3 is 36. So I'm working with 9 over 36. Now these numbers are getting a little bit smaller. I can start to do these in my head. If you cannot, keep going with your calculator. I know my 9 is divisible by 9. I know my 36 is divisible by 9. And I end up with 1 over 4. Can I reduce that any further? No, I cannot. So 324 over 1,296 is really just a fancy way of writing 1 over 4. And we can find that without being able to recognize, hey, what is the greatest common factor between these two pieces? Just by finding common factors and breaking them down piece by piece by piece, we were able to break this into its most reduced form. So I'm hoping at this point, if you followed along, you're feeling a little bit more comfortable reducing your fractions. I'm hoping you're feeling a little bit more comfortable working with many fractions being multiplied, many fractions being divided, and being able to turn it into a form that is easier for you to work with.